Assalamu alaikum guys, welcome back. Okay, so now we are gonna move on to the real portion of period 3, that is the chemical reactions of all the elements of period 3. These are the major reactions that we have to cover in this from this video onwards, okay, for like maybe 2 to 3 videos. Okay, so let's begin. Okay, so reactions of period 3's element, okay, chemical reactions of period 3 element. The first type of reactions that we are gonna do is the elements reacting with oxygen, meaning the combustion of elements in presence of oxygen. Okay, that's one type of reaction and I've written them down over here. I'll come to them in just a bit. Then the second type of reaction that we have to do are the reactions of the oxides of period 3 with water. Of course, they'll react with oxygen, they'll form oxides, right, after reacting with oxygen. So those oxides, what sort of reaction will those oxides have when they react with water? Okay, either they are insoluble or soluble, or if they are soluble, then do they react or dissolve and stuff like that. Okay, then reaction of oxides with acids and bases. Okay, if the oxides are, of course, if they are acidic, then they will react with bases. If they are basic, they'll react with acids, and we'll look at them one by one. Reactions of the elements with the chlorine. Okay, chlorine will produce chlorides, most of them, some of them, or you'll just look at them. Reactions of chlorides with water. The chlorides that we get after this reaction, either they dissolve or they react with water, meaning they hydrolyze in water or do they dissolve in water. That's also a process that I'll explain later on in these videos. And then the uses and the experimental effects of period 3 elements. Okay, so this was a broad overview of the different types of chemical reactions that we are going to kind of cover in period 3. So now let's first of all, let's start out with elements, the reaction of the elements with oxygen. Alright, so now let's Bismillah ar-Rahman ar-Rahim. Okay, so first element is sodium, right? Sodium metal. Sodium metal, when it is burned in oxygen, it burns with a yellow flame. Okay, we are burning it, we are combusting it. Okay, this is complete combustion. Okay, so sodium reacting with oxygen, forming sodium oxide. This sodium oxide is a white solid. Okay, this observation is important. You are sometimes asked to state the color of the oxide. Okay, so it's a white solid and it's ionic in nature. Okay, it is ionic solid and it is a basic solid. Okay, it's an alkaline solid. Basically, it will dissolve in water to produce alkali, and basically it will produce sodium hydroxide, and yeah, that's it, soluble in water. Then these observations are very, very important. Okay, it burns with a yellow flame. Yellow flame is important because the flame color is asked. Okay, and if you leave out sodium in open air, on top of its surface, on top of its superficial layer, the sodium will react with the oxygen in the air slowly but gradually, and it will react and its surface will change its color. We say that sodium has tarnished. Okay, so sodium tarnishes in when it is left open at room temperature. Okay, but if you burn it in presence of oxygen, it will produce sodium oxide, but if you leave it, it will tarnish. Okay, it's only its superficial layer will get coated with sodium oxide, and of course that reaction is going to be slower. Now the takeaway point from here is the flame color, the color of sodium oxide, white basically, and its properties. Okay, now coming to magnesium and this equation as well, of course. Okay, you are supposed to write down the equation, the complete balanced equation as well. Then coming to magnesium, when magnesium reacts with oxygen, it produces magnesium oxide. Magnesium oxide again is a giant ionic lattice containing compound. Okay, it is a ionic compound, it has a giant ionic lattice, it is used as a refractory material. Remember, we did that in the previous lectures, and it is used to line furnaces. All of these questions are actually linked with magnesium oxide. When they are, the examiner, what the examiners love to do is mixing different components of different chapters. Okay, for example, magnesium oxide was covered back in the beginning as well. So its major use is lining of furnaces because of its high temperature. Why high temperature, high melting point? Why? Because of its ionic bonds. So stuff like that can come in. But over here it is a white solid. Powder ash would be formed as soon as you burn magnesium ribbon or magnesium strip in air, in oxygen. Okay, as soon as you burn it, the magnesium ribbon, it will convert into a white powdery substance, white ash of magnesium oxide. Okay, and the color is gonna be intense white, brilliant white flame. This is the key term you must include in your answer. Okay, a brilliant white flame would be observed. So this is the takeaway point from here, the intense white flame and the equation and its color. Then coming to aluminum. Aluminum reacts with oxygen to produce Al2O3, aluminum oxide. Well, if you leave out aluminum in the atmosphere, openly basically, then aluminum has a very special property, and that is aluminum quickly reacts with the oxygen in the atmosphere and creates a protective Al2O3 layer around it. Okay, if you take a piece or block of aluminum, leave it in air, it will not tarnish very easily. Why? Because it will quickly react with the oxygen which is available on the in the atmosphere and create an inert layer on top of it, and this inert layer will prevent further reaction of the inner aluminum with the oxygen outside. Okay, so apparently aluminum does not react with oxygen, but if you burn it, where is it? If you burn it, meaning if you heat it up in air, then it will burn with a yellow flame. Okay, again flame color is important, but at room temperature it doesn't react, meaning apparently it doesn't react. You would see the framework that you have at your homes or at your offices, which is made up of aluminum, it appears to be the way it was let's say a year ago. Reason? Because it does not readily react due to the Al2O3 protective layer on top of it. But over here, if you burn it, it will produce Al2O3, but with a yellow flame it is gonna burn. And Al2O3 again giant ionic lattice, and it has some covalent character as well, but it's mainly ionic. Okay, then coming to silicon. Silicon, guys, remember we did silicon, it has a very high melting point, right? Giant covalent structure. Similarly, when it reacts with oxygen, it produces SiO2, but it does not react with oxygen at room temperature. It burns in oxygen. Okay, you have to burn it at a very high temperature, only then will you get silicon dioxide. Silicon dioxide, silica, sand, it is something you've already done in your O levels. It is a giant covalent and insoluble in water. Okay, silicon 4 oxide is another name for silica, silicon dioxide. Okay, 4 because its oxidation state of silicon over here is +4. Then coming to phosphorus. Phosphorus reacts with oxygen to produce P4O10, phosphorus 5 oxide. P4O10 is also known as phosphorus 5 oxide. Okay, 5. The 5 is written in brackets, by the way. Let me just write it down over here. Phosphorus 5 oxide. Okay, P4O10. This P4O10 sometimes in your MCQ options it is also written as P2O5. Okay, P2O5 is actually the empirical formula of P4O10. Same thing. Okay, now this P4O10, when the phosphorus reacts with oxygen, the P4O10 that you get, it is actually you'll observe white fumes. Okay, the smoking fumes would be observed, and they'll be dense and they'll be white in color. This is very important observation. Okay, when this reaction occurs, it will react it will burn with a yellowish white flame, again yellowish white. Okay, not a different flame color, but dense white fumes would be observed. This is an acidic oxide, and this has a simple molecular structure. Okay, not a giant covalent structure like SiO2. It has a simple covalent structure. Okay, so if it is a simple covalent structure, that's why it is a gas. These are white fumes. Okay, whereas SiO2 is a solid. Then it is also acidic and it is soluble in water, whereas SiO2 was insoluble in water. Phosphorus can also react with oxygen to produce P4O6, meaning phosphorus 3 oxide. Okay, this is when it reacts with 3 moles of oxygen. That is when it reacts with 5 moles of oxygen. Okay, this is also an acidic oxide, and it also has a simple covalent structure. Then coming over here, the last, sulfur. Sulfur, when reacts with oxygen, it produces sulfur dioxide, and the flame color of sulfur is very, very important. And it is the unique flame color. It is different from all the other flames you've seen so far. It burns with a blue flame, blue flame. Okay, and it is very nice to see. Like I love this flame color. I observed it in the laboratory, and like it was fun looking at it. But still, it is a beautiful color that would be observed, blue flame, when sulfur burns in oxygen to produce sulfur dioxide. And when this sulfur dioxide, if it is left in the atmosphere, in the atmosphere, basically, which is actually the sulfur which is produced from the fumes or from the chimneys or from the factories where sulfur containing fossil fuels are combusted. Basically coal, C-O-A-L, coal is a fossil fuel which contains sulfur. Okay, by the way, coal reserves, coal ores do contain lots of sulfur. So when coal is combusted in the industries, in the factories, it produces sulfur dioxide. Huge amount of sulfur dioxide is produced from the chimneys. Now this sulfur dioxide which is released into the atmosphere, in the atmosphere it can oxidize to sulfur trioxide. Okay, it can oxidize to sulfur trioxide. This balancing is very important because this equation has been tested quite a few times to be balanced. Okay, examiner asks you to balance this equation. 2 sulfur dioxide produces 2 sulfur trioxide when it reacts with oxygen, and this is a slow reaction. Okay, this occurs in the atmosphere, and this equation is very important even in the contact process, meaning manufacture of sulfuric acid. We'll be doing that in a bit. No, sorry, not here. We'll be doing that in equilibria, but over here, the contact process, vanadium 5 oxide is the catalyst that is used to produce sulfur trioxide. This sulfur trioxide in that process then dissolves in sulfuric acid to produce oleum, which is concentrated sulfuric acid, H2S2O7, and then it is diluted to sulfuric acid. But anyways, you don't need to go, we'll be discussing that later on. But over here, this blue flame is very, very important, and these oxides are very important. Both are acidic oxides, again simple covalent or simple molecular structures are there, and this completes the reactions of the elements with oxygen. So the flame colors are very important, the observations are very important, the color of the oxides are very important, the nature of the oxides are very important. Ionic oxides till Al2O3, covalent and all covalent, whereas this is giant covalent and the rest are simple covalent. Okay, and this completes the reactions of elements with oxygen. Then in the next lecture we are going to start out with the reactions of oxides with water. Thank you.